Hello everyone, today I am going to talk about SSTOs, or what has been considered for a long time the kind of holy grail of rocket science. Now SSTO means single stage to orbit, and what that implies is a launch vehicle that can reach orbit from a liftoff without staging or without losing parts essentially. This of course has many advantages. It would make it easier to build a reusable rocket, or at least that is a common thought, since you only need to handle re-entry, which is actually quite difficult from orbit, so it might actually be a bigger advantage to recycle the first stage without having full orbital velocity re-entry. So that's, for example, why SpaceX isn't directly going into SSTO research right now, but it does have its advantages. It means that you can land the whole thing in one part. You don't need as much work to recycle it, and you can land it on your spaceport without needing a drone ship or a boost back burn and the fuel for a boost back burn, since the whole craft ends up in low Earth orbit, and you can then just plan and time your deorbit burn and your re-entry so that you land just at your spaceport. However, there are more advantages to SSTOs. They are also much simpler, as you don't need a staging mechanism or the additional parts for fuel systems and engines for 2 stages. So they would be simpler, cheaper, more reliable. But there's a little problem, that is they are really difficult to build, since they require engines and fuel tanks that are so lightweight that they can actually carry themselves all the way into orbit without needing staging to extend the delta V that is available to them. The problem being that most fuel tanks and engines can just so hold and lift enough fuel to bring themselves into orbit without carrying any payload or re-entry systems. Of course, there are several approaches to dealing with this. One approach is that you just build better fuel tanks and better rocket engines. This has long been thought almost impossible, but the technology is actually kind of there. There's a company named Arca that is doing research into SSTOs, although for now planning to build expandable SSTOs, which are not reused but are simply cheaper than normal rockets because they are simpler. They actually use aerospike engines, which have another big advantage, that they not only have a good thrust-weight ratio but also have good efficiency over a long range of different atmospheric pressures, since they essentially adjust on their own. However, this is not really necessary. It helps a lot, but while a vacuum optimized engine doesn't really perform at all in atmospheric pressure, an atmosphere optimized engine actually performs only slightly worse than a vacuum optimized engine in vacuum. So the aerospike engine is quite a technical breakthrough, and it does help building SSTOs, but it's not actually necessary. And in fact, if you run the numbers, theoretically SpaceX kind of has the technology to build an SSTO at this point, though it's not really tested for flight yet, but they could start developing one. The Raptor engine has been ground tested, and it has the best thrust-weight ratio of any rocket engine at this point, of any Spaceflight capable rocket engine at this point. Of course, engines in things like air-to-air missiles have extreme thrust-weight ratios, but that's for different reasons, and they are not really useful for spaceflight. And they have also built first samples for purely carbon fiber-based fuel tanks, which would allow to carry a lot of fuel compared to their own weight, enough to actually bring more than just that fuel tank into orbit. However, SpaceX is currently not really putting any development in SSTO programs, although the BFR, that is the big Falcon rocket that is meant to transport the ITS, might actually be usable as an SSTO with a smaller payload, but that's at this point for future development, and it's not really intended to be used this way. They plan to use it with the ITS own engines actually making the circularization burn, and thus adding a little bit of delta V, making it not quite an SSTO with that payload. And they have good reason for it. It would currently not quite be worth it. It would be a lot of development cost, and it wouldn't really have a big advantage since they're already going into reusability research, and the Falcon 9 can already land its first stage. They're working on the second stage, although that is not really planned. They have announced that they might test re-entering and reusing the second stage in the future, but they're not really planning on it, and it's probably not really going to be worth it either at this point, at least with the Falcon 9. And in this case it just seems to be more advantageous for lower cost spaceflight to not go SSTO and just build as efficient as possible reusable rockets that do stage and do actually potentially lose the second stage, but still reuse the first stage, than build an SSTO that could only deliver a very small payload compared to its own mass into orbit. Of course, maintenance is also a big problem for any potential SSTO programs, as an SSTO would require a lot of maintenance, and that might actually make it more expensive than cheap expendable rockets. And since it's operating on the very edge of what's possible with thrust to weight ratio, it also can't be built with a big margin of safety. Still, even expandable staging rockets don't really have that big a margin of safety, as they are already very lightweight, but they can still be built with a bigger margin of safety than an SSTO could be, and thus an SSTO would be more maintenance heavy and more expensive high tech than even nowadays staging rockets. Of course, there are also other plans or other concepts for SSTOs than just improved rocket engines. There are plans to use scramjets or just jet engines in combination with rocket engines, or rather before rocket engines, to climb and speed up through the atmosphere, and only then use rocket engines to leave the atmosphere and go into orbit. For example, the Skyloon spaceplane is one concept that is relatively far developed and might actually fly in the mid-future. And then there are a lot of purely hypothetical concepts, like using nuclear rocket engines to gain a better specific impulse and thus make it easier to build SSTOs. There are also a lot of other additional hypothetical concept techniques that could be used to make orbital launches easier, which I might go into detail over in later videos, but which could also be used to make building SSTOs easier. Of course, technically we have already built an SSTO a very long time ago. That is, in the 60s, the Apollo lunar ascent stage was capable of reaching low moon orbit from the moon's surface in one stage, but that is of course a lot easier than doing the same thing on Earth with less gravity, a smaller body, and no notable atmosphere. Though that does beg the question of the technical definition of an SSTO. As for Earth-based launches, it turns out while SSTOs would be really cool and might make spaceflight a bit cheaper than expandable staging rockets. It might not be the best way to make spaceflight cheaper given the current advancements in staged landing techniques that SpaceX and other companies research at this point. And while the SSTO has been seen as a kind of a holy grail idea of rocket science, ever since it was essentially first came up with, since the first rocket scientists came up with the idea of an orbit at all, in fact, it took the first experimental rocket programs a while to figure out that with the technology at that point it was not possible to build an SSTO and then come up with the idea of staging in the first place. It might not be the best way for cheaper spaceflight, at least in the near future, although possible. Now, as always, I hope this was kind of interesting, and thanks for watching.